Hello everyone, welcome to Equal To, and this is episode 14 of our number systems playlist. If you haven't watched the past 13 videos yet, please go and check them out. I'll give you a link here. If you have watched those videos, we can start with this one, and we are going to solve the rest of the example questions in the 1.4 sections, which is operation on real numbers. Okay, we are starting with example 16, and the question goes like, rationalize the denominator of 1 divided by root 2. So this is the question, 1 divided by root 2, and you're supposed to rationalize the denominator. Now, a couple of videos back, we ended up discovering 3 inferences, right? One of those inferences were multiplying 2 irrational numbers might leave you with a rational number. Okay, so that is one of the inference that we gained from that set of examples, right? I hope you have watched that and you remember that. Okay, now that is the exact property that we are going to use it in this case. We know that root 2 is irrational and we are supposed to rationalize it, and we know multiplying 2 irrational numbers might lead to a rational number. So that is exactly what we are going to do, and for that we are going to multiply this 1 divided by root 2 by root 2 numerator and denominator. We cannot simply multiply only the denominator, that doesn't work, right? Why doesn't it work? Because that simply breaks the number, it becomes a different number. So just multiplying it by root 2 at the denominator makes it 1 by 2, that's a whole other number. Okay, so the value shouldn't change, that is the rule of maths, right? So 1 divided by root 2, for you to rationalize it, you are going to multiply this number by root 2 at the numerator and denominator. Okay, so what does that leave you with? That leaves you with root 2 divided by root 2 multiplied by root 2, and root 2 multiplied by root 2, as you know, is actually 2. So the final answer is root 2 divided by 2. Okay, and this obviously the denominator here is just 2 and 2 is a rational number. Okay, so we have fulfilled the purpose of rationalizing the denominator. So this is a very simple question. There is nothing complicated here. We are just using one property, that is multiplying 2 irrational numbers might, not actually always, might sometimes give you a rational number, and that we have used here to convert the denominator into a rational number. Moving on to the next example, this is also very similar to the first question or the example 16 that we just saw, but you are just going to use a couple of different techniques here. Okay, so let me just rewrite the question here. It's 1 divided by 2 plus root 3. Okay, now the denominator here is actually irrational. Okay, 2 plus root 3 is irrational, we know that for sure, because root 3 is irrational, and by adding that to a rational number, you also make the entire number as irrational. So what we are going to do is that we are going to use something that you already know, which is a plus b into a minus b equals a squared minus b squared. We know this. Okay, we have seen this in the previous video in detail. Now we are going to use this very same thing to rationalize this denominator. How exactly are we going to do that? Now in this denominator we have 2 plus root 3, right? Now let us just assume what happens if this 2 plus root 3 is multiplied with 2 minus root 3. Okay, now for you to rationalize root 3, it has to be multiplied with root 3, okay, or it has to be squared. Both are just same. Okay, so what we are going to do is that we are going to take 2 minus root 3 and we are going to multiply that with 2 plus root 3. Now this thing is of the form a plus b into a minus b here, right? It is of the form a plus b into a minus b. So you can just tell that this can be expressed in the form of a squared minus b squared. So that would just be 2 squared minus root 3 squared. Now by doing this, you are converting root 3 into 3 and that becomes 4 minus 3, that is just 1. Right? So the denominator can easily be rationalized. So that is what we are going to do here. Okay, you are going to multiply this with 2 minus root 3. So let us just have that aside, and you are going to multiply this with 2 minus root 3 divided by 2 minus root 3. Obviously you have to do this both at the numerator and denominator, right? So multiplying this, you would be getting 2 minus root 3 divided by 2 squared minus root 3 squared, and that we know is 2 minus root 3 divided by 1, right? 2 squared is 4, root 3 squared is 3, 4 minus 3 gives you 1. So the answer simply is 2 minus root 3. Okay, it's just plain old 2 minus root 3. And the question is 1 divided by 2 plus root 3. Okay, so this is how we have converted the denominator into a rational number. In this case, the denominator is just 1, right? 1 is the denominator here, and that is a rational number. So we have rationalized the denominator. Okay, understood? Now moving on to the next question, which is also similar to the question that we just saw in example 17. It's very similar. Okay, so we have the number 5 divided by root 3 minus root 5. Now also here we have root 3 minus root 5. So we can use the same thing again. Okay, what is that? A plus b into a minus b is a squared minus b squared, right? We are going to use the same thing here, and we are going to multiply this numerator and denominator with root 3 plus root 5. Okay, now by doing this, we can make the denominator of the form a plus b into a minus b, and that can be further used to convert it into a squared minus b squared, right? So let us first worry about the denominator now. Let the numerator be that way. So 5 into root 3 plus root 5. Okay, and in the denominator we have just converted into a plus b into a minus b, right? So root 3 minus root 5 into root 3 plus root 5. So it is of the form a plus b into a minus b, which as we obviously know is a squared minus b squared. So just to convert it, it's 5 multiplied by root 3 plus root 5 divided by root 3 squared minus root 5 squared, right? Root 3 squared gives you 3 and root 5 squared gives you 5, right? So 5 into root 3 plus root 5 divided by 3 minus 5. So 3 minus 5 is minus 2, right? So this can also be written as 5 root 3 plus 5 root 5 divided by minus 2. Okay, whichever way is fine with you, you can write it. It doesn't really matter if, yeah, it doesn't really matter if you write it with 5 or not. Okay, 5 can be outside the bracket or 5 can be inside it, as I have written here. I am just struggling with moving this right. Okay, so this is the answer for this question. 5 root 3 plus 5 root 5 divided by minus 2, and I'm sorry, the denominator here is minus 2, and minus 2 is obviously a rational number. So we have rationalized the denominator of this question. Moving on, we have the last question of this video and the last example of this section, and that is example number 19. Okay, now we are given a similar number and we are going to rationalize its denominator. Okay, so we are going to use the same concept that we have been using for the past two questions. You guessed it right, it's a plus b into a minus b is equal to a squared minus b squared. Okay, we are just going to use the same technique here. So let me just rewrite the question again. So 1 divided by 7 plus 3 root 2, and we are going to multiply that with 7 minus 3 root 2 divided by 7 minus 3 root 2. Okay, so that is going to give you 7 minus 3 root 2 divided by a squared minus b squared, right? So 7 squared minus 3 root 2 squared. So what exactly does that value come up to? So 7 squared is 49, minus 3 squared is 9, and 9 times 2 is 18. Okay, so let me just write it once again here. So 9 into 2. Okay, root 2 squared is 2 and 3 squared is 9. So it's 18. Okay, so 7 minus 3 root 2 divided by 49 minus 18. So that is 49 minus 18, 31, right? So that is 31. So the answer is 7 minus 3 root 2 divided by 31. And that is the answer to this question. Okay, I hope you have understood this. We are again using the same concept, a plus b into a minus b is equal to a squared minus b squared. And we have solved 4 examples in this question, and in all of them we have rationalized the denominator. Okay, I hope you understood these things. If you have any questions or doubts, please feel free to put them in the comments. I'll get back to you as soon as possible. Thank you so much for watching this video. See you in the next video. Bye for now.